This video accompanies the Right Triangle Trig Application Practice Problems worksheet, and I'm going to talk you through the problems and how to set them up. So at any point when you think, oh, I know how to do the rest of the problem, pause the video and finish the problem yourself. It'll be better practice for you. I'm going to start by going through the first problem, which is actually worked out for you, but just to talk it through. In all of these problems, we're going to create a right triangle with given information. So here we have a ladder leaning against the tree. If I drop a perpendicular line down here, I have a right triangle. So I'm going to draw my right triangle over to the side. I know one side is 6.7 meters. That's the hypotenuse of the triangle. And I know this angle is 63 degrees. And I want to find the height, which I'll just call x, the height up to the cat. Now, anytime you have two pieces of a right triangle given, and you want to find a third piece, you can always use Sohcahtoa. In this case, I know that the x is the side opposite 63, and 6.7 is the hypotenuse, and opposite and hypotenuse are related using sine. So I know that sine of theta is equal to opposite over hypotenuse, so I can say sine of 63 is equal to x over 6.7. Solving that for x just means I'm going to multiply both sides by 6.7, and I just plug that into my calculator. Now there's two options for plugging this in. We've been in radian modes all along, so if I'm still in radian mode, I can add a degree symbol, or I can change my calculator into another mode. So let me just show you this. If I go to sine of 63, now at this point I'm going to add a degree symbol. You go to your pi symbol, and right underneath is the degree symbol. And I guess I forgot to put in there 6.7 times sine of 63, and there's my answer. If I wanted to change it to radian mode, or radian degree settings, I'm sorry, go to menu, scratch that, go to control menu, escape, nope, go to your document setting, there we go. So when you're in the document, go to, push the dock button, go to settings and status, and see you can change, let's see here, that's not it, cancel. I thought I knew this off the top of my head. So dock button, settings and status, okay, I just, document settings. So dock, settings and setting, document settings, and then I can change my angle to degrees, okay. Now right now I've just made it for this document only. So now if I type in 6.7 sine of 63, it'll calculate it as degrees automatically. So those are your two options. And the answer then would be 5.969 radians, since, or 5.969 meters, since that's we're in meters here. So the height of the ladder, 5.969. And typically in a story problem, I'm not going to go beyond the number of significant digits in the given information. So I'm going to round this to one decimal place, 2 significant digits. That would round to about 6 meters. Okay, now let's look at our second problem. Now we still have a cat in a tree. Now the cat is in the neighbor's tree, so this is a different tree, a different yard, and a different ladder. We're going to use the neighbor's ladder. So so you don't refer to any of the other information from the previous problem. Notice here we have a ladder, an angle, and we have a distance from the tree here, and we could once again drop a line down here and make a right triangle. So this would be my right triangle. In this case, I know this is 7.5 feet. This is 55 degrees, and I want to find the length of the ladder. So it's pretty much the same setup, only this time I know the adjacent side, and I want to find the hypotenuse, and the trig function that relates adjacent and hypotenuse to this angle would be cosine. So I'm going to say cosine of 55 degrees is equal to 7.5 divided by x. Now be careful. A lot of people want to just say, oh, x is 7.5 times cosine of 55. No. X times cosine of 55 is equal to 7.5. Therefore, x is equal to 7.5 divided by cosine of 55 degrees. Once again, you can plug that in and find the answer using either degree symbol or making sure your calculator is in degree mode. Okay, number 2, if side AC is 4 meters long, okay, that would be the hypotenuse, 4 centimeters long, and side BC is 3 centimeters long, what is the measure of angle A? So this is what I'm trying to find out. So where are these two sides in relationship to angle A? 3 is the side opposite, 4 is the hypotenuse, so I'm going to use sine. So sine of, and I'll just call my angle theta because I don't know what it is, so sine of theta is equal to 3/4. Well, I need to do an inverse sine here to find this. So theta is equal to inverse sine of 3/4. Once again, I need to be either in degree mode or I need to change over. So let me show you what happens if I'm not in degree mode when I do this. First of all, in degree mode, here's what the answer should look like. Inverse sine of 3 divided by 4. Okay? Oh, one of those crazy things again. Control Enter. There we go. 48.6 degrees. That looks pretty reasonable. Now, what if I had been in radian? So let me change back to radian mode just to show you what it would look like if I was in radian mode. So one thing you should be able to recognize is what an answer looks like in the other mode. So now that doesn't look reasonable that it would be less than 1 degree. That really doesn't look reasonable. That is in radians. Now can I change that to degrees? Yes, there is a way to do that if you want to stay in radian mode and just change to degrees. Get that number, you do Control and this little book icon that it's the catalog, and you're going to pick up a symbol that's near the top here. Let's see here. There we go. This symbol. Enter. Come on. Okay, and then you're going to type in DD for decimal degrees. That changes it to degrees. Okay, so the symbol is under Control Book, and it's a little kind of a caret, sideways caret, a little arrow kind of thing. Okay, back to our problem. So that turned out to be 48 something. That's in the key. Okay, this one, little trickier. I want to find the height of the water tower. So I need to know this distance from here to here. Well, notice this is referred to as an angle of elevation, 31 angle of elevation, and this 26 is referred to as an angle of depression. Angles of elevation and angles of depression are always measured from the horizontal. So this line is exactly horizontal, which means it's parallel to the ground here. So we can, and then of course the height of the water tower is perpendicular to the ground, assuming they didn't build a leaning water tower. That means these have to all be right angles. Okay, so we've got right angles there. If this is a right angle down at the base, I'll draw it on the other side. If that is a right angle, then these are also right angles. So we have 2 right triangles. And I need to find this whole distance, but in order to do that, I have to do these right triangles separately. I could find, we'll call this A sub 1 and A sub 2, and I want to add those together. A sub 1 plus A sub 2, then it's going to give me A. So if you can figure out how to do this from now, maybe stop and do this. If you need to keep going, here we are. I know this length right here is the same as this length, which is 290. So I have a triangle that looks like this, 31 degrees here, 290, a right triangle, and I'm trying to find this, A sub 1. And I also have a triangle that looks like this, 26 degrees, 290, and A sub 2. So what relates 31 and the opposite side and the adjacent side? Well, that would be tangent. So I have tangent of 31 degrees is equal to A sub 1 over 290, and tangent of 26 degrees, so speak degrees, is equal to A sub 2 over 290. So 290 times tangent of 31 degrees is equal to A sub 1. 290 times tangent of 26 degrees is equal to A sub 2, and then A sub 1 plus A sub 2 would give you your answer. How high is the window? Well, this distance is the same, since these two lines, let me kind of draw here, since this line, this horizontal line is parallel to this line, then B and A sub 2 should be the same length. So you don't even have to actually do any more calculations. A sub 2 and B are the same. So whatever you got for A sub 2 would be your answer to B. Okay, last one, we have a tree casting a shadow. Here's the sun. Okay, the sun hits, at the sun's angle as it hits the top of the tree, creates a shadow here, which forms a right triangle. Once again, assuming our tree is perpendicular to the ground, as trees should be. And we know that the height of the tree is 109. So if we draw our triangle over here, that's the tree, that's the shadow, 109, 130. We're trying to find the angle of elevation. Well, that would be the angle measured up from the horizontal that you would have to look in order to see the sun. And don't stare directly into the sun, that is dangerous. So we're talking about that angle right here. Once again, we would relate this using tangent. Tangent of theta is equal to 109 divided by 130. But in this case, now I want to find what theta is. So theta is inverse tangent of 109 over 130. And then you just calculate that, making sure you are in degree mode. So that's just a quick synopsis of how to do right triangle problems. Usually the trickiest part is figuring out how to use the given information and put it on the triangle. These are fairly simple ones. We'll get to more challenging ones very shortly.